ran into some problems that came from the nature of we were interested in operating environments that basically had multiple versions of OpenFlow live at the same time. We were interested in multiple different implementations of the OpenFlow data plane. And we were interested in multiple versions of software firmware loads actually running on these systems. And so we started to quickly run into problems because, as a lot of you know, there are many versions of OpenFlow. We get one every year. There's more in the works. There's a lot of variability within the protocol. Some of the features in the protocol themselves are not really additive. They're added, other features are withdrawn. They may use the same value number sometimes. So actually using the message layer as an interface isn't exactly something that's stable if you want to build an application that kind of runs in a homogeneous way or a heterogeneous way. And something else that we just kind of noticed that wasn't obvious to us when we started the project about 18 months ago is almost everything that you typically think of as an OpenFlow feature is really up for grabs. You kind of need to determine if that feature is present before you blindly start hammering a device to figure out if that device can support the actions that you actually desire. So, you actually need to determine if what you're trying to do is possible. You need a fairly extensive amount of data on them for when things actually aren't possible or things go wrong. It turns out there's a subset of knowledge that you actually depend on when you're configuring OpenFlow that you can't actually learn through OpenFlow itself. You actually have to learn a priori. Long story short, it's not really for the average programmer. We're not eager to make things easier at this time. And so what we actually wanted to propose is, what about a tiny MBI? What about something along the lines of a sockets-like interface that focuses on the data model first and the protocol second? That we actually have clean bindings to. It doesn't worry about addressing any issues of high availability or distributed operation. It's purely focused on abstracting OpenFlow protocol specifics and variability specifics out of the equation. I'm talking one slide ahead. And of course, the other thing was we wanted to try and support cross-language binding very easily. So first, what we wanted to do was focus on the data model. So we went through all the existing versions of OpenFlow up to 1.4. We kind of inferred the underlying data model that comes out of that system. And we really realized there's three aspects to the data model. There are abstractions. Abstractions have three parts or three views on them. There's capabilities, like the things that the abstraction can do. There's configuration, the state that affects how it's actually going to behave. Sometimes you can just read it, sometimes you can read or write it, but of course there's statistics, all those abstractions. So we actually went through the process of defining an explicit data model, coming up with these views, going through what they actually look like, and they produced something called Tiny MBI. We also defined an application lifecycle, so what it means to load, unload, start, stop the application, guarantees that might apply. We looked at resource allocation models, so rather than hitting specific memory addresses, you should actually hit things that are allocated. And then the last thing, of course, was non-native feature offload. And yeah, we don't have much time, so come talk to me if you have any specifics.
All right, so this is talking to Jason. Anybody have a question for Jason? Well, while Conti's setting up, can you incorporate also some sort of interface like OFconfig into this? Can you support this? We can.
So yeah, there's actually several ways of getting information about the target switch state. There's OFconfig, there's the things through HotSDN, there's newer something called table type patterns. So these are sources of